Hi everyone, my name is Luis Ureña, and my major is computer science, and my linear algebra topic is transformations, and how they relate to one another is image transformations with computer vision. And the reason why I chose this topic is because one time we were like renting a car that had this cool feature that was like a bird's eye view of the car using just the cameras that are on the side of the car. And I've always been curious how that works, so this gave me an opportunity to look more into it. And I have to be honest, I don't completely understand it, but I'll walk you through what I found and what I kind of understood from it. And I definitely do want to keep looking into it. So I'll lead you through here to what I found. So like just a quick like recap. Um, this, if you don't remember, um, this is a image transformation of a rotation with the angle theta here. And so this is the transformation, and these are your x and y values for one vector, and then out. This is the resulting. And so then I started Googling like how computer vision relates to linear algebra. And I came across this topic called perspective rectification. Um, and you can see here they took like a picture that was of a whiteboard that was at an angle, and then they like made it look like it was flat. So then I started Googling more on the topic of perspective rectification. And then I stumbled across a homework assignment for a professor from UC Santa Barbara. And so the assignment was to use this image right here to try and rectify this image on the left. And so from my understanding is you get points from this image. For example, I think you could use like, for example, this banner. Take 4 coordinates, and then you're supposed to solve for this middle matrix. Of course, a computer can do it for you. And that's what I found here. And so what the output looks like is shown here. As you can see, it doesn't show the entire thing. It just shows it kind of like, because there is some data that the image doesn't entirely capture. So that's why it's like skewed a little bit. And I was trying to look more into it. There's another question that says here, use the function image transformation. You need to pass the inverse of the transformation, I believe here. And I tried to look for it, and I did find it. Here's what it looks like. It's really long. I don't understand all of it, but you see it shows like the image, the original image that has to be transformed. Then T is the homogeneous transformation matrix, which is the one we solved, I believe. This, you can leave it blank because I don't know what the fourth element does. And yeah, it kind of like, this is something, it was part of the professor's like algorithm that he made. So I found that. And then when I was actually like looking up this tutorial, I was looking more of like how this can be actually implemented. And this one kind of goes through some of it. it goes through some pictures later that get rectified into one long image, like the I mean, take like a panorama on your phone. And oh, I went to this guy's channel who turned out to be like a professor in New York that works at a research institution, university, or something like that. Um, and he posted a video, and I'll show like a small clip of it. But all these videos like clearly use linear algebra image transformations. Um, Also augmented reality. So pretty cool stuff. It's not just used like in one sector. And yeah, I definitely want to look more into this topic on my own for fun. Um, and yeah, that concludes my presentation. Thanks for watching.